For this problem, we are given three resistors, two of which are in series, R2 and R3, and then if we combine these, we will get R2, R3, and we can see that this is in parallel with our R1. So we're going to have to do some math and find out what the R equivalent will be. For our R in series, we will be using this equation, and for our R in parallel, we were going to be using this equation. For our R series, we are just going to add them together. So we are going to have R2 plus our R3. In the problem, we are given R2 as 601,382 ohms. We are given our R3 as 24,902 ohms, and we will get 626,284 ohms if we add these together. Now R1 and R23 are in parallel, so this formula is going to have us enclose them in a bracket, and we are going to have 1 over our R1 plus 1 over our R23, and this is going to be raised to the negative first power. Our R1 is given as 34,520, and then our R23 we found to be 626,284. If we raise this to the negative first power, we are going to get 32,716 ohms approximately of resistance. If you don't know where these equations come from, there'll be a link below, the top link, with a super basic fundamental understanding of how resistors in series and resistors in parallel can be calculated. If you want more advanced problems, they will be just below that. And if you want a playlist that deals with these problems, that'll also be below in the Chapter 3 section.